This slide presents a C-rate analysis of 48-volt lithium-ion battery pack using Matlab Simulink software. So here you can see this is the problem statement. We have to design a 48-volt battery pack with capacity of 25 ampere hour. Considering the load resistance 1.92 ohm, cell specification nominal voltage is 3.7 volt. We are using here lithium-ion battery. Capacity is 12.5 ampere hour. The objective is to determine the equivalent load resistances corresponding to discharge rate of 1C, 2C and C by 2 and to simulate the battery electrical behavior under this loading condition. So under the mathematical solution section, the analysis starts by identifying the C rate reference currents, which define how fast the battery is charged or discharged relative to its capacity. At 1C, the battery discharges at 25 ampere. At 2C, it discharges at 50 ampere. At C by 2, it discharges more slowly at 12.5 ampere. So in the next, we calculate the equivalent load resistance for each of these C rate by using the Ohm's law, R equal to V by R. This value helps in simulating real-world operating condition for battery. For 1C 25 ampere, the resistance is calculated as, we already calculated this as the design battery pack voltage, that is the 48.1 divided by 25, and the resistance is 1.924 ohm. For the 2C, so resistance value will be the 0.962 ohm, and for C by 2 the resistance value will be 3.848 ohm. So this resistance value will be used to model the battery under different loading condition during simulation. So here you can see for the 1C section, it means the battery is completely discharged within 1 hour, and that time the resistance value is 1.92. For the 2C, here the battery takes only 30 minutes to completely discharging, means 100% SOC to 0% SOC, when the resistance will be 0.96. For C by 2 means the battery takes almost 2 hours to completely discharge, and that time the resistance will be 3.848 ohm. Now let's go ahead and implement this analysis in Matlab Simulink software. For the C-rate analysis, I am taking the same configuration 48-volt battery pack with capacity of 25 ampere hour. 13 cells are connected in series and 2 cells are connected in parallel. So for the initial case, I am taking 1C when the resistance was 1.92 ohm. So here we see that the battery takes 1 hour to completely discharge. Now for the 2C means it takes faster time to discharge. 2C means it takes only the 30 minutes to completely discharge. For that we require the load resistance as 0.96 ohm. So just double click on the resistance and change the resistance value as 0.96 and then apply. Okay, so it takes only 30 minutes. So here the run time will be the 1800 seconds. Okay, now just run the program. So here you can see the corresponding current measurement as well as the corresponding the voltage measurement. From here we can easily find the battery voltage, current and the SOC. So here you can get the output. Double click on the scope. So here you can see it takes 30 minutes to completely discharge. So initial SOC is 100% and within 30% its SOC is 0%. Here you can see this SOC curve is continuously decreased. So here is the current profile as well as this is the voltage profile. So this is for the 2C charging, 2C discharging. So now we am taking C by 2 C rate. C by 2 C rate meaning it takes hours to completely discharge the battery. So during the C by 2 rate, we calculate the load resistance as 3.84 ohm. So just I am going to the RLC series branch. So here I am taking 3.84 ohm and just apply, and then I am taking here the second is 2 hours, means 7200 second. Just click on the none button and wait for it. So here you can see corresponding the current measurement and also corresponding to the voltage measurement across the load resistance. Now double click on the scope. So here you can see it takes almost 2 hours to completely discharge. So here you can see this is the 100% FOC and it takes 2 hours to completely discharge the battery. Here you can also see the current profile, and also here you can see this is the voltage profile of the battery. Okay. So here you can see for the 1C charger, we calculate the load resistance as 1.92 ohm. For the 2C charging rate, 2C means it takes almost 30 minutes to completely discharge the battery. We calculate the load resistance as 0.96 ohm. For the C by 2, it means it takes 2 hours to complete the discharge the battery. This is basically slow C rate. And for that we calculate the load resistance as 3.84 ohm. So you have to design this 48 volt battery pack with capacity 24 ampere hour, and just you have to change the load and you have to calculate the load resistance to check whether it will be the 1C, 2C or C by 2 charging rate. Okay.